Hello, my name is Pablo Enrico. I am a specialist on the research and development team at S.I.N, and today I want to talk to you about the new implant capture system. The drilling sequence for the Versalis implant is very simple and intuitive. Now, let's start with the lance drill exercise. We'll make the initial marking now. At a speed of 1,200 revolutions per minute. Next, we will move on to the 2.0 millimeter drill. The rotation remains steady and consistent at 1,200 revolutions per minute. At this stage, we will carefully choose both the angulation and the depth for optimal results. In this case, I am placing a 13 millimeter implant. So, following the company's official recommendation, I will carefully drill 2 millimeters deeper for safety and precision. Now, if for any reason you ever need to change the angulation of this implant, as recommended, we have the specialized Linman drill available for this purpose. The rotation remains exactly the same at this point, and now I can precisely set the necessary angulation that I want. We will now carefully follow a step-by-step sequence specifically designed for soft bone procedures. At this stage, we are using the 3.5 millimeter drill, and we are drilling again, this time to the full depth of 15 millimeters, making sure that it remains 2 millimeters below the crest of the bone. The next drill to be used in this process is the 3.8 millimeter drill. Please note that it is important to drill only up to this specific marking as indicated. Take your time to ensure accuracy at each step. The last drill to be used for soft bone, which is bone with a lower density, is the 4.0 drill, and you should continue to follow the same dashed line as before to ensure accuracy. If the bone were harder, meaning it had a higher density, we would use a smaller drill to avoid applying too much force. Let's move on to the bone drill.
Also at a depth of 15 millimeters for the placement of a 4.0 x 13 millimeters implant.
At this point in the procedure, if the cortical bone in the area is found to be very dense, we can use the countersink drill. With this particular drill, the first marking will ensure that the implant is placed precisely at the bone level. The second marking, however, will position the implant so that it is 2 millimeters below the bone crest. This is exactly what we are going to do now. At this point, we use the depth probe, which comes from the conventional implant side, to carefully determine if the depth of the drilled site is correct and appropriate for the implant. I drilled to a depth of 15 millimeters and then used the depth probe to check and confirm that the depth matches exactly what I intended and planned for this procedure. And the direction indicator corresponds to the diameter of the implant I want to place, to check if it is positioned at the correct and intended depth. Note that it has specifically designed indentations, which are present to make visualization much easier and clearer in radiographic exams. The selected implant, in this particular case, has a diameter of 4 millimeters and a length of 13 millimeters, providing the necessary support. We gently press the box with our fingers, making sure to apply even pressure, and then carefully remove the wrapper from around it. Carefully access the blister pack. For implant placement, we need the installation driver. Please note that this driver features a tip made of PIC material, which is specifically designed for this purpose. This allows for better adaptation and helps to hold the implant more securely and firmly in the driver. On the implant cap, you can clearly see the selected size and its connection type, which are important details to verify. To open it, you need to turn it a quarter of a turn, and then the implant is securely held in place with a strong titanium connection. The implant must always be carefully picked up using the special key, together with the driver, With the contra angle, and without ever touching the implant directly with your hand, proceed as instructed. The connection must be made completely and thoroughly in order to hold the implant securely in place. To break this strong titanium connection, we need to carefully perform a lateral braking motion. Notice that there are no extra or residual titanium fragments left at the apex or very tip of the implant.
At a rotation speed of 20 to 40 RPM, we should bring the implant to the site in a horizontal or vertical orientation, facing upward to avoid accidental release. Once at the site, we position the implant and begin its insertion. From this point on, we have two options. We can either use a torque wrench with the pre-selected torque along with the installation driver, where this driver fits completely inside the implant, and with your index finger on top, we turn it until we reach the selected torque.
Once the desired torque is carefully reached, it will then perform this brake process.
The other option we have is to use a beam-type torque wrench. With it, we will similarly attach the insertion driver.
And from there, I can carefully observe and determine if the torque is increasing progressively step by step and what the final torque value will be at the end. So I proceed to insert the implant to the desired depth, ensuring it is positioned correctly, and then I check the torque once again. Due to its aggressive macro geometry, which is specifically designed for optimal performance, we are able to achieve excellent and reliable torques. According to the official recommendations from the company, the implant should be positioned 1.5 to 2 millimeters below the bone line. And we can verify and confirm this with the help of the direction indicator.
The blister pack lid, where the implant was, you must pull, detach, and observe that we have an implant cap inside it. With the 1.2 hand driver, we engage it.
And the installation on the implant, which has now been successfully completed.